as for operating the engine. So this is our focus. Actually, hydrogen is used for a number of applications like fuel cell and for other applications also. So in our case, hydrogen will be used as fuel and it will be combusted. Actually, in our fuel cell, we will not combust the hydrogen. Hydrogen will combine with oxygen and electricity will be produced in fuel cell. But in our case, our discussion is focused on using hydrogen as fuel, like our conventional diesel or gasoline. How to use hydrogen as fuel in our internal combustion engines, in SI engine or in spark ignition, in compression ignition engines. So this is the focus. Let us start with the introduction. So we know very well about the energy crisis. So energy is an important resource for the development of a country. However, its availability is limited. If you look at this figure, this figure shows the past, present, and future energy consumption of the world. So, are you able to see the slide?
Sir?
Are you able to see the slide?
Yes, sir. Visible, sir.
That is visible. Okay. So this figure shows the energy consumption of the world. If you look at this slide, in the earlier days, in ancient days, people started using wood as the energy source, just for heating purpose, for cooking, for producing heat. People used wood. Then after finding the availability of coal, people started using coal as the fuel for heating purpose and also for power production. Later on, after the discovery of that petroleum resources, the petroleum fuels have come into picture. Even now, we use petroleum products for our energy and power. And if you look at this figure, in the future, it is expected that the fossil fuel resources will be depleted. Definitely, they are going to be depleted. But the energy demand, every day, every year, the energy demand of the world is increasing steadily. Rapidly, it is increasing. So, if you look at in another 20 years, definitely the energy demand of the world will be twice or thrice the energy demand of today. At the same time, if you look at the future, in the future, fossil fuel resources will not be available in the earth. So it is expected that in the future, only renewable fuels only will dominate. Renewable fuels only will dominate. So what are all the renewable fuels available on the earth? If you look at this slide, we have a number of renewable fuels. We have gaseous and we have liquid fuels. We have liquefied petroleum gas, natural gas, hydrogen, biogas, producer gas. So these are all the gaseous fuels available on the earth. And we have liquid fuels like alcohols and vegetable oil, even animal fat. So these are all the available alternative fuels on the earth. And we have to focus on using all these alternative fuels because all these fuels are renewable fuels. So we have to focus. In our case, we are going to see the use of hydrogen. There are a number of fuels. We have alcohol, we have vegetable oil, etc., etc. My focus is on hydrogen. So in our case, in our discussion, we are going to discuss the production methods, as I told you in the last slide. Production methods, then combustive properties, problems associated with the hydrogen, and rectifying the problems. Then we will discuss some of the results of hydrogen-fueled spark ignition engine. Then we will come to the closure. We will discuss also the storage techniques for hydrogen. Okay, now let us start with the introduction with the hydrogen. So hydrogen, if you look at hydrogen, we know very well about the hydrogen. Hydrogen is generally it is produced from the renewable source water. So water is renewable, available in plenty. We can easily produce hydrogen from water by the process called as electrolysis. And if you look at the properties, features of hydrogen, hydrogen has unique and desirable properties to use in internal combustion engines. And if you combustion of hydrogen will result only in water, H2O. No other emissions like gasoline or diesel. We will not have any CO, hydrocarbon, particulate, smoke, or any other emissions from hydrocarbon fuels. So combustion of hydrogen will result only in water. Obviously, if you use air as the oxidizer, we will have oxides of hydrogen also, but combustion hydrogen will result only in water. So, because of these attractive properties, hydrogen is considered as an excellent fuel of the future. But the unique properties are dangerous also. So, we will discuss what are all the properties and how to rectify that. Before going to see the properties of hydrogen, let us see the production methods of hydrogen. So hydrogen, if you look at hydrogen, uh, so hydrogen is produced by number of methods. The well-known method of producing hydrogen is by electrolysis. We are aware of electrolysis, breaking the water molecule by passing the current, we can produce hydrogen. So this is the well-known technique. But generally speaking, hydrogen is produced in bulk, mass production, industrial production. Hydrogen production in bulk can be by steam reforming by the process called as gasification, by the process called as gasification. So in the gasification, in two stages, hydrogen can be produced. So at a very high temperature and also at a low temperature. So at 1000 degrees centigrade, we can produce hydrogen, and also at 130 to 150 degrees centigrade, we can produce hydrogen. So these are the two important reactions where we can get hydrogen in bulk production, mass production of hydrogen. Generally, industrial hydrogen will be produced by the gasification. So gasification, you know about gasification. Gasification is nothing but partially oxidizing the biomass. So partially oxidizing the biomass will produce CH4, methane. So methane is the important gas for producing hydrogen. So methane will be reacted with water at very high temperature during the gasification process. Actually, during the gasification process, the biomass, any biomass can be partially oxidized. So partial oxidation will result in number of products like a CH4, CO, CO2, etc., etc. Number of gases, but the main gas produced from gasification is CH4. So that CH4 will be reacted with water at very high temperature, and we can produce hydrogen. So this is the basic process involved in producing hydrogen. On the other hand, we can react natural gas. Natural gas, instead of going for gasification, we can directly react in natural gas with the hydrogen, with water. With water, this is called as steam reforming at very high temperature. Reacting water with CH4 will result in hydrogen. So this is one of the reactions. Yeah, at a low temperature also during the gasification process, the remaining CO present here will be further reacted with water, and we can obtain hydrogen. So these are the two techniques coming under gasification. The two techniques used for producing hydrogen in bulk, in mass. Apart from this gasification process, by electrolysis, we know very well about what is electrolysis in our laboratory. We can produce hydrogen by electrolysis of water. So electrolysis is breaking the water molecule by passing the current. We can get hydrogen. But electrolysis of water will give small amount of hydrogen only, small amount. But for going for mass bulk production, we have to go for gasification. Apart from this electrolysis of water, we have ammonia dissociation. Ammonia dissociation also a part of a process involved in producing hydrogen. Apart from ammonia dissociation, we have other methods also, like hydrocarbon, reacting hydrocarbon with some other gases will result in hydrogen as the byproduct. So those things are other methods, but the main method for producing hydrogen is by the gasification process. Gasification. In gasification, in two stages, at high temperature and at low temperature. In two stages, we can produce hydrogen in bulk. So this is the production method of hydrogen. Next, let us discuss the important properties of hydrogen. Very important properties. What are all the properties? If you look at the properties of hydrogen, hydrogen has extremely unique properties. Extremely unique. Unique means totally different from other hydrocarbon fuels. Totally different. I mean, the properties are extremely unique. For example, if you look at the flame speed of hydrogen is highest flame speed of all the fuels. So like that, hydrogen has the unique properties. So the important properties, combustive properties of hydrogen are wide range of flammability limit, low ignition energy, small quenching distance, high auto ignition temperature, high flame speed, and high diffusivity. So these are all the important combustive properties of hydrogen. Let us discuss one by one. Wide range of flammability limit. What is flammability limit? You are aware of flammability limit. So flammability limit is nothing but the range of air fuel mixtures. We have a lean mixture, rich mixture, stoichiometric mixture. So we have different types of mixtures, air fuel mixtures for achieving combustion. So we have a lean mixture. With lean mixture also we can achieve combustion. With rich mixture also we can achieve combustion. With the stoichiometric also we can achieve combustion. Flammability limit is the extreme lean and rich mixtures. Extreme lean mixture, extreme rich mixture. Within that, combustion is achieved. Beyond that, we cannot have combustion. So the range, the limit within that combustion is achieved is called as the flammability limit. And within the flammability limit, we will have the stoichiometric air fuel mixture. So, do you understand what is flammability limit? Because this is very important. Audience.
Yes, sir.
So you are aware of a stoichiometric air fuel ratio, right? So, for example, 14:1, you are aware of 14:1 as the stoichiometric air fuel ratio for gasoline. But 14:1 is for the complete combustion. If the air fuel mixture is 12:1, then also we can achieve combustion. But the combustion may not be complete. At the same time, if you have 8:1 rich mixture, 8:1, then also you can have combustion, but the combustion will not be complete. But there will be combustion. But there are limits. There are limits. Beyond that, you will not have combustion. Do you understand what I'm saying? So 14:1, for example, gasoline has 14:1 as the stoichiometric air fuel ratio. But if the air fuel ratio is 5:1, for example, 5:1, then you will not have combustion. You will not have combustion. At the same time, if your air fuel ratio is 20:1, then also you will not have combustion. So there are ranges between lean and rich mixtures. Within that, combustion is achieved. Is called as flammability limit. So, this slide can show you the flammability limit in terms of volume. Actually, I have given in terms of volume. So if you look at the flammability limit, For gasoline, it is 1.4 to 7.6. For diesel, 1 to 5. Actually, I have given in terms of volume. In terms of mass, this will be 14 is 14. This range will this range will vary. 14 is stoichiometric. So here, what I wanted to say is the flammability limit for gasoline is 1.4 to 7.6. So between this one, you will have stoichiometric. But if you look at for hydrogen, you have 4 to 75. 4 to 75. So the range is widest range of all the fields. So wide flammability or widest flammability limit. So hydrogen has the widest flammability limit. So because of this widest limit, what is the advantage? If you ask, the advantage is that even we can operate the engine in very lean condition. I told the flammability limit means the range of air fuel mixtures within that combustion is achieved. So hydrogen with very lean mixture also we can achieve combustion. So the main advantage of this widest flammability limit of hydrogen is we can have fuel economy. We can save fuel. We can have fuel economy. So this is one advantage. So significant advantage of hydrogen wide flammability limit is we can operate the engine in lean side and fuel economy. Fuel economy can be greater with hydrogen. So this is one important advantage of hydrogen. So next, if you look at the next property, low ignition energy. So ignition energy required for igniting the hydrogen fuel air mixture. Fuel air mixture for all the fuels will have certain ignition energy required for getting ignited. So if you look at the ignition energy for hydrogen, hydrogen has low ignition energy. For example, if you look at the energy required, minimum energy required for igniting the hydrogen, the requirement is 0.019 millijoules. Very small ignition energy. So the thing is that hydrogen can be ignited very easily. So you will have confusion with low ignition energy and high auto ignition temperature. So these two things are something confusing. I will tell you clearly the difference between this one and high auto ignition temperature. So low ignition energy, if you look at the ignition energy, for example, for igniting the gasoline air mixture in our spark ignition engine, for igniting the gasoline air mixture, we need 20,000 voltage, 15,000 voltage, very high intensity we need. Very high intensity spark is used for igniting the gasoline air mixture. In case of hydrogen, you need not have that kind of very high intensity spark because the hydrogen can be easily ignited. Even a hot spot, inside the combustion chamber will ignite the hydrogen. So in one way, this low ignition energy is advantageous because we need not have any sophisticated ignition system for igniting hydrogen, and we need not have any very high intensity spark. Small voltage, 500 volt, some kind of a small voltage is sufficient for igniting hydrogen. So in one way, this is advantageous. At the same time, this low ignition energy is not advantageous. Unfortunately, if you look at the low ignition energy, because of the hot spots present inside the combustion chamber, you know what is a hot spot. So can anyone tell one example for hot spot in engine? Hot spots, one example.
Exhaust valve.
Yes, heated exhaust valve tip, heated spark plug terminals. Very good, very good. Piston top face of that piston.
Carbon
So
deposits.
okay. So in the engine, you have a number of hot spots, even glowing carbon particles inside the combustion chamber. When the engine is continuously running, the engine combustion chamber parts will be completely heated. So the combustion chamber parts, heated combustion chamber parts like exhaust valves, spark plug terminal, piston top, all the things will act as hot spots. So that the temperature can be sufficient for igniting hydrogen. So this low ignition energy in one way it is advantageous. On the other hand, it is not advantageous because of the hot spots, because of the low ignition energy, and with the help with the hot spots, you will have premature ignition. Pre-ignition, you are aware of pre-ignition. So in our, for example, in our spark ignition engine, the combustion will take place at the end of compression. So during suction, air fuel mixture will be admitted. During compression, air fuel mixture will be compressed. At the end of compression only, you will have spark produced. After the spark, you will have combustion. But in our case, because of the pre-ignition, because of the hot spots present during the suction itself, when the hydrogen air mixture is admitted inside the combustion chamber, you may have possibilities for igniting the hydrogen. So during suction itself, if hydrogen fuel mixture is ignited, then what will happen? Then you will have inlet valve. During that period, inlet valve will be opened. So the flame propagation will be through the intake manifold also. So pre-ignition is an important process which is occurring in our hydrogen fueled engine, which is an unwanted one. It is an unwanted one in hydrogen fueled engine. So pre-ignition will occur because of the low ignition energy. So we have to overcome the pre-ignition. So low ignition energy, the second property we have discussed. The third property is small quenching distance. Actually, small quenching distance means the hydrogen can quickly reach the combustion chamber wall. Hydrogen flame, generally in our spark ignition engine, you will have flame propagation. During the during the combustion, the flame will be propagating. It will be consuming the unbound mixture, and it will be propagating in all directions until it reaches the end of the combustion chamber. And when the combustion chamber parts, the combustion chamber wall, if combustion chamber wall is at low temperature, then the flame propagating through the unbound mixture may not reach the end of the combustion chamber. So before reaching the end of the combustion chamber, the flame will get extinguished. So this is called as flame quenching. But in our hydrogen case, the hydrogen flame can quickly reach the combustion chamber wall because of, actually, the small quenching distance is somewhere it is related with high flame speed also. So the thing is that the hydrogen flame can quickly reach the combustion chamber wall, cylinder wall, quickly reach the combustion chamber wall. So the flame quenching will be eliminated in our hydrogen fueled engine. So small quenching distance. So flame quenching can be minimized if we use hydrogen as the fuel. So we have seen wide flammability limit, low ignition energy, then high auto ignition temperature. So this is something confusing. I told hydrogen can be easily ignited. So that means that for igniting hydrogen, you need small amount of energy, but you need some ignition source. But in this case, auto ignition temperature means the fuel, the minimum temperature at which the fuel gets ignited automatically. Do you understand the difference between the low ignition energy and auto ignition temperature? Actually, auto ignition temperature is the minimum temperature. See, you are keeping one fuel in a closed chamber and you are simply heating. At what temperature the fuel is automatically ignited without any ignition source? So that temperature is called as the self-ignition or auto-ignition temperature. If you look at the self-ignition temperature of hydrogen, hydrogen has the highest self-ignition temperature of all the fuels. If you look at the self-ignition temperature of diesel, it is approximately 260 to 280 degrees centigrade. For gasoline, it is approximately 450, 460 like that, even 400. It depends upon the hydrocarbon percent in gasoline. So generally speaking, gasoline has a higher self-ignition temperature than diesel. Because of the low self-ignition temperature of diesel, in diesel engine, diesel is automatically getting ignited, auto-ignited. Whereas if you look at hydrogen, hydrogen has highest self-ignition, 570 degrees centigrade. 570 degrees centigrade. It has the highest self-ignition temperature of all the fuels. So from this high self-ignition temperature, we can say that hydrogen cannot be directly used in diesel engine. Because in diesel engine, diesel is ignited automatically by the heat of compression. Air is compressed, diesel is injected. By the heat of compression, diesel is automatically ignited. Whereas if you use hydrogen in the diesel engine, hydrogen cannot be combusted because the self-ignition temperature is higher. Higher means very high than diesel or any other fuels. Very high auto-ignition. So this means that auto-igniting the hydrogen is very difficult. But with the help of a small ignition source, we can easily ignite. So this means I used to tell one simple example for the ignition energy and auto ignition temperature. For example, I will tell one example. You have in our Deepavali festival and all, we use sparklers, no? That sparklers. The sparkler, if you want to ignite a sparkler with the help of the candle flame. So in the candle flame, with the help of the candle flame, you are trying to ignite, fire the sparkler. So if you want to use candle flame for igniting the sparkler, then it will take much time. Instead of that, you have another firing sparkler, and just if you touch your sparkler with the firing sparkler, then immediately you will have the sparkler getting ignited. You understand? What I wanted to say? Do you understand what I am saying? So I'm telling for the ignition energy.
Yes, sir.
Yes, sir.
So the sparkler needs high ignition energy. That high ignition energy can be provided by the another firing sparkler. The candle flame cannot provide the sufficient ignition energy for the non-firing sparkler. So like that, hydrogen, for igniting hydrogen, you can have a small ignition energy, but if in the case of auto ignition temperature, for auto ignited, hydrogen needs more temperature. So if you look at the temperature of the candle flame, if you look at the temperature of the candle flame and if you look at the temperature of the firing sparkler, the temperature will be almost same. The temperature will be same, but the ignition energy provided will be different. So that is the thing I wanted to tell. So hydrogen needs low ignition energy, but in the case of auto ignition temperature, hydrogen's auto ignition temperature is very high. So without any ignition source, automatically for getting ignited, hydrogen needs more temperature. 75-80 degrees centigrade. See, this high auto ignition temperature, in one way, it is a drawback for using hydrogen in diesel engine. We cannot use hydrogen in diesel engine directly. I'm telling why hydrogen is preferred to be used in spark ignition engine. Why not in diesel engine? One of the reasons. This is one of the reasons I'm telling. Hydrogen has very high auto ignition temperature. Because of the very high auto ignition temperature, hydrogen cannot be automatically ignited in diesel engine. So the final thing is that hydrogen is not preferred. Hydrogen should not be used in diesel engine, but we can use it. There are methods to use hydrogen in diesel engine also, but the general thing is that hydrogen is preferred to be used in spark ignition engines only. And if you want to use a hydrogen in spark ignition engine, the other advantage of this auto ignition temperature is in our spark ignition engine, because of the high auto ignition temperature of hydrogen, we can increase the compression ratio of a spark ignition engine. Generally, the compression ratio of a spark ignition engine is from 6 to 9. Whereas in diesel engine, the compression ratio is 16, 18, even 20 also. So the compression ratio is very high for diesel engine. In a spark ignition engine, compression ratio is limited up to 9 due to knocking. So if the compression ratio is increased in our spark ignition engine, then you will have knocking combustion. That's why compression ratio is limited by knocking in spark ignition engine. Whereas if you use hydrogen, as fuel in your spark ignition engine, then you can increase the compression ratio. You can increase without having any problem of knocking. Without having knocking problem, you can operate your spark ignition engine with hydrogen as fuel. So as per our ideal Otto cycle, you are aware of Otto cycle. So the thermal efficiency, Otto cycle efficiency is purely depending on the compression ratio. 1 minus 1 by R power gamma minus 1. That R is the compression ratio you are aware of. So if the compression ratio is increased, then automatically your thermal efficiency will be increased. So this is the advantage of hydrogen. புரியுதுங்களா? Are you able to understand? Hello?
Yes, sir.
Huh?
Yes, sir.
So if you don't, yeah, you can in the middle also you can raise your, you can pose your questions, because sometimes
sir,
the audio may
Yeah,
not
sir,
be. Audio
Yeah,
may
sir.
not-
Yeah, sir. Yeah, sir. So
Yeah.
participant may interact. Sir will be
Yeah.
happy. Happy
Yes,
to address
yes,
your
yes.
question.
Yes.
Excuse me, sir.
But let me complete. But
Yes.
what I wanted to ask is, if you have any audio problem or any kind of disturbance, networking problem and all, then you can tell me. I will stop. For clarifications, I will complete in another 15 minutes. Then we will discuss. We will have discussion, long discussion if you want. Okay. So regarding the auto ignition temperature, I told you clearly. So the hydrogen has very high auto ignition temperature. So the advantage of this high auto ignition temperature is, in spark ignition engine, we can increase the compression ratio. For example, in spark ignition engine, we are having the existing compression ratio as 9. The 9 can be increased to 12 if you want to use hydrogen in that engine. With 12, you can use hydrogen without having any knocking problem. So in that case, you will have more thermal efficiency. Instead of having thermal efficiency of 28 with gasoline, you can have the thermal efficiency of 32 also with the hydrogen. So that advantage is possible with hydrogen as fuel in spark ignition engine with the high auto ignition temperature. So next property is so auto ignition temperature. Next property I can tell you, low ignition engine, small quenching distance, high flame speed. I think I discussed the flame speed, right? High flame speed.
No, sir.
No, sir.
Yes. So the next property is the high flame speed. So flame speed is after the ignition, how long the flame travels per second or per hour. If you look at the flame speed of the hydrocarbon fuels, the flame speed of gasoline, diesel, methanol, ethanol, etc. For all the hydrocarbon fuels, if you look at the flame speed will be between 30 to 50 centimeter per second only. So the flame speed for all the hydrocarbon fuels particularly at stoichiometric conditions. At stoichiometric conditions, if you look at the flame speed of all the hydrocarbon fuels, the flame speed will be between 30 to 50, or for some cases it will be 60. But if you look at for hydrogen, hydrogen has the highest flame speed. See, widest flammability limit, lowest ignition source, highest flame speed, highest energy content. So like that, hydrogen has unique properties. So it is very, very attractive, unique, very attractive. At the same time, the unique properties are very dangerous. See, I told high flame speed, highest flame speed, approximately 10 times, 8 to 10 times higher the flame speed of other hydrocarbon fuels. So 300 meters per second, that is 300 centimeters per second, 3 meters per second. So within a second, per second, it travels, the hydrogen flame will travel 3 meters. Very high flame speed. So in one way, this is advantageous. High flame speed is advantageous because immediately after the ignition, the flame will quickly reach the end of the combustion chamber. In our spark ignition engine case, we have the spark before the piston is reaching the top dead center. At the end of compression stroke, we have the spark and we will have ignition. Then the flame front will propagate through the unbound mixture, and during the expansion only you will have the end of combustion. So this is called as the progressive combustion. So the progressive combustion means the combustion has some period of time. Combustion spreads over a period of time. Combustion involves combustion duration. For spark ignition engine, if you look at the combustion duration may be 30 to 40 degree crank angle. 30 to 40 degree crank angle. And if you look at for hydrogen, if you use hydrogen as fuel, the hydrogen flame speed is very high, 300 meters per second, 300 centimeters per second. Because of the very high flame speed, immediately after the ignition, the hydrogen flame will immediately reach the end of the combustion chamber. Very quickly it will reach. So this means that the combustion duration is minimized. And the combustion will approach the ideal Otto cycle. So we are aware of Otto cycle. So in Otto cycle, if you look at the Otto cycle has a constant volume combustion. So in our Otto cycle, heat addition is at constant volume. But in the real case, in the real spark ignition engine, the combustion is not in constant volume. Combustion spreads over a period of time, 30 degree, 40 degree crank angle, it spreads. So it's not exactly constant volume cycle. It is a progressive combustion cycle. But if you use the hydrogen as fuel in our spark ignition engine, you can approach the constant volume combustion. So if you have a reduction in combustion duration, then definitely you will have very high thermal efficiency. So with the high flame speed, you can achieve constant volume combustion, and also you can have higher thermal efficiency. So this is about the advantage. At the same time, because of this high flame speed, you may have possibilities for backfire. I told in the earlier slides that hydrogen has low ignition energy. So because of the low ignition energy, you will have premature ignition. Premature ignition with high flame speed, you will have backfire also. So I will discuss more about that one in the forthcoming slides. So if you look at the flame speed, the advantage is that you can achieve constant volume combustion. Otto cycle combustion, close to Otto cycle combustion, you can. But generally speaking, in any spark ignition engine, achieving constant volume combustion is very difficult. Combustion duration, it involves combustion duration. If you in any engine, if you reduce the combustion duration, then you will have improvement in thermal efficiency. So this is the basic idea. But with the help of hydrogen, you can achieve reduction in combustion duration, and your thermal efficiency can be more. At the same time, this high flame speed is dangerous. So the dangerous aspect is that you will have flashback. I will tell you later on the problems. So this is about high flame speed, high auto ignition temperature. I told you. Then if you look at the diffusivity of hydrogen is a very light gas, and it will quickly dispose. It will quickly move out. In case of our LPG, in case of any leakage occurring in our LPG cylinder, we observed in many places the gas explosion, gas cylinder explosion done. So this is because of the accumulation of the fuel. So in case of leakage, LPG will be accumulated nearby the cylinder itself. Whereas in our hydrogen case, in case of any leakage, hydrogen will move out. It will disperse quickly, rapidly. So in one way we can say that hydrogen is safe to handle because of the high diffusivity. Then hydrogen has low density. If you look at the density, hydrogen has the it has very low density. So the advantage of low density is it can quickly mix with air. So air fuel mixture preparation can be easily achieved with hydrogen as fuel. In our gasoline case and all, we have carburetor. Carburetor is used for mixing the air and fuel at appropriate ratios, and the carburetor is used for supplying the air fuel mixture, chemically correct air fuel mixture. For that, in our conventional carburetor, we have number of systems, auxiliary system, acceleration pump, etc., etc. We have additional systems. Whereas in case of hydrogen, we need not have any sophisticated carburetor for mixing the air and fuel. So it can easily mix with air. So because of the low density, it can easily mix with air. So this is the another property. Then if you look at the stoichiometric air fuel ratio, hydrogen has the stoichiometric air fuel ratio of 34:1. Actually, I have mentioned in mass. Actually, here in mass basis, I have mentioned. If you look at the stoichiometric, air fuel ratio of gasoline has the stoichiometric air fuel ratio of 14:1, 14.7:1, whereas hydrogen has the air fuel ratio as 34:1. So that means that in the conventional engine, hydrogen can be operated at very lean mixture. So when compared to gasoline, small amount of hydrogen is sufficient for achieving the same power output of the gasoline engine with gasoline as fuel. So that is the thing. And if you look at this table, I have discussed all the properties. Here the other important properties are the calorific value, the energy content in mass basis per kg. I'm telling about per kg because hydrogen is in gaseous form. So in mass basis, if you look at the energy content, hydrogen has the highest energy content per kg. Gasoline has 47, diesel has 45 megajoule, whereas hydrogen has the highest energy content. The other important property is the octane number. The octane number of hydrogen, if you look at the octane number of hydrogen has higher octane number than gasoline. So this is another important property. Higher octane number can help in increasing the compression ratio. Can help in increasing the compression ratio. So the hydrogen has another benefit of having higher octane number than gasoline. So perfectly suitable for spark ignition engine operation. Whereas if you look at the C10 number of hydrogen, actually I have not given the value of C10 number. It is approximately 5. C10 number is 5. That's why hydrogen should not be used in diesel engine directly. So the important reasons I can tell, if someone asks you about hydrogen, can we use hydrogen in diesel engine? We can say no. Why? The important reasons are hydrogen has very high self-ignition temperature. So we cannot ignite hydrogen in diesel engine. The second thing is that hydrogen has very low C10 number, very low C10 number. So we cannot use hydrogen in diesel engine directly. But there are methods for using hydrogen in diesel engine, like dual fuel mode of operation. Whereas if you look at the properties of hydrogen, the hydrogen is best suited for using in spark ignition engine. And we can have many advantages of using hydrogen in spark ignition engine if appropriate modifications, appropriate control techniques are adapted in our spark ignition engine, we can use hydrogen efficiently in spark ignition engine. So these are all the things about combustive properties. So if you look at the combustive properties of hydrogen, hydrogen has unique properties. I already told you: widest flammability limit, highest flame speed, highest energy content, highest auto ignition temperature. So all the properties, almost important properties, are unique. We cannot compare at all. Unique properties. At the same time, the unique properties are dangerous. So the dangerous properties are the low ignition energy. I told the energy required for igniting hydrogen is very, very, very small. So even a hot spot can ignite the hydrogen air mixture. So because of the low ignition energy and because of the very high flame speed, you will have problem of pre-ignition and backfire. So these are all the problems associated with hydrogen. Because of the low ignition energy, okay, wider flammability limit. The important thing is that very high flame speed. Because of the very high flame speed, you will have pre-ignition. So that is the thing I told you. Actually, pre-ignition means before occurrence of the regular spark. If ignition occurs in the combustion chamber, then we call that as pre-ignition. So I already told you, during suction, we are admitting the air fuel mixture. During the suction stroke, you have intake valve opened. Intake manifold is directly in contact with the combustion chamber, and you have the air fuel mixture admitted. At the time, if you have ignition, then what will happen? You will have the flame propagation. Flame, because of the very high flame speed, flame will go back through the intake manifold and it will reach the hydrogen cylinder. So this will have dangerous explosions. And once if the hydrogen cylinder is exploded, if it explodes, then what will happen? The hydrogen, we have seen that the flame speed of hydrogen is 3 meters. So you will have dangerous, effects. So handling hydrogen is very, very, very dangerous. That's why still the research is focused on using hydrogen. Still, it has not come to the commercial usage. So there are a number of biofuels used. Hydrogen is not used yet in our automobile. The thing is that the safety is the problem. Fuel handling and safety. Fuel handling and safety. In addition to fuel handling and safety, another problem is storage of hydrogen. I will discuss in brief the storage at the last in the last slide. I will discuss. So the problem associated with the hydrogen is
What is when?
சொல்லுங்க. Hello? Yeah, you can.
So I think by fault it has been unmuted, sir.
Which one is unmuted? Oh, no problem. You can. You can ask. Any questions or shall I continue?
Please, sir, continue.
We will discuss later on after the end of the session. We will discuss. So the problem is pre-ignition. I told what is pre-ignition, then backfire. So because of the extreme properties like lower ignition energy, highest flame speed, widest flammability limit, all these things, you will have pre-ignition and backfire. So this must be prevented. Otherwise, you will have dangerous effects with the hydrogen as fuel in our internal combustion engine. Now, how to overcome the problems? So in different ways, we can overcome the problem. The solutions for overcoming the problems are actually there are different ways where we can do modifications in controlling preignition. The first one is by doing modification in the fuel supply system. By doing modification in the fuel supply system, we can carefully introduce hydrogen inside the combustion chamber, and we can eliminate preignition and backfire. So the under fuel delivery system, we have different ways of supplying hydrogen. The easy way of supplying hydrogen is by fixing a carburetor at the intake manifold. Actually, carburetor means not the carburetor whatever we use for our petrol engine. Not that type of carburetor. Simply a venturi tube. A venturi like arrangement. A venturi tube can be used as the carburetor, because the hydrogen can easily mix with air. So here, or you can simply make a small hole on the intake manifold. Just you can make a small hole and you can fix a small tube here or probe. Through the probe, you can supply hydrogen. So this is the simple way of supplying hydrogen. Or by using the gas carburetor, you can supply hydrogen without having any sophisticated equipment. You can supply hydrogen. But this carburation may have the carburation, because of this carburation, you have chances for backfire, because the flame, actually carburetor is fixed at the intake manifold only. Because of this one, you will have the distance. You have some distance here. Through the distance, you may have possibilities for backfire. But the easy way of supplying hydrogen is just by making a small hole on the intake manifold, or by using a venturi tube, or by using a gas carburetor. You can easily supply hydrogen. So this is the easy way of supplying hydrogen. But there are more possibilities for pre-ignition, backfire to occur. So in this type of arrangement, what we can do before supplying hydrogen into the intake manifold, we can place a flame arrestor, flame trap. We can place a flame trap. By the use of flame trap, we can avoid backfire. So flame trap can be placed here at the intake manifold, and we can supply hydrogen safely. So this is a simple way of supplying hydrogen, but there are possibilities for backfire. So instead of going for carburation, we can also use hydrogen injection. We can make. We can fix an injector at the intake manifold by timed injection. By timed injection, you can avoid backfire, but still you have distance. Here you have the distance for the flame to travel back. So there are possibilities for flashback, but as compared to carburation, this method can minimize the flashback. Instead of going for injecting the hydrogen at the intake manifold, we can also inject hydrogen at the intake port directly. So this intake port, injecting hydrogen at the intake port can minimize the flame travel here in case of any backfire. It will minimize. But this system is somewhat complicated as compared to carburation, because in this case you must have electronic injector, then control, everything you must have. But this system is a bit complicated. For completely eliminating backfire, flashback, you can directly inject hydrogen inside the combustion chamber. So this is incidental injection, direct injection of hydrogen inside the combustion chamber. So directly injecting the hydrogen inside the combustion chamber will minimize the risk for flashback or backfire. So, sir, how long I have to? It is at 12:45. Can I take another 15 minutes?
Yeah, sir. Please, sir. Please, sir.
15
Please.
minutes or 20, if you permit me.
Yes, sir. You can go, sir. Up to 1 o'clock works.
Okay, sir. Okay.
1 or 1:15 you can go.
Okay, sir. Okay. So this is about direct injection of hydrogen. So this direct injection of hydrogen inside the combustion chamber will completely eliminate the flashback or backfire. So this is under fuel delivery system. So by doing modifications in different places in the engine, we can minimize or eliminate the pre-ignition and backfire. So one of the solutions is by doing modification in the fuel supply system. So I have shown you the possibilities for supplying hydrogen safely. Next method is we can adopt a thermal dilution. So you are aware of what is thermal dilution, because the combustion of hydrogen is very erratic, so rapid, very, so erratic. Because of erratic combustion, you will have flashback, backfire, and also your combustion chamber parts will be unnecessarily heated up. So we can control combustion of hydrogen by adopting thermal dilution techniques. So you are aware of what is thermal dilution? It's the exhaust gas recirculation, water injection. So these are some of the techniques used for controlling the combustion rate of hydrogen. Exhaust gas recirculation, you are aware of, taking a small part, 5 to 10% of the exhaust gas, and supplying the exhaust gas along with the intake manifold will help in controlling the combustion of the fuel. This is adapted in spark ignition and diesel engine also. Particularly in our hydrogen combustion, we can go for EGR or controlling the combustion rate. The next one is introducing water along with the charge during the intake. During the intake, we can introduce 2% of 2 to 3% of water. By introducing water inside the combustion chamber, also we can control the combustion rate. So this is coming under thermal dilution. Then by doing modification in the engine design, we can control, we can reduce the risk of pre-ignition and backfire. So under engine modification, we can go for disc-shaped combustion chamber with flat piston. For example, in our diesel engine, you will have a bowl in piston. In diesel engine, you will have bowl in piston. In our petrol engine, sometimes you will have projections, some projections, or even you will have bowl in the piston. So that kind of arrangements should not be there in our hydrogen fueled engine, because those things will act as hot spots. So prone for hot spots. So we can avoid having that kind of arrangements like bowl and piston, or having any projections on the piston top or the combustion chamber parts. So by eliminating those things and by using the flat piston, something like this, flat piston, without having any projections, with a flat piston, you can minimize pre-ignition. And actually, this is the flame arrestor. This flame arrestor can be placed in case of carbureted carburation. In case of supplying hydrogen through carburation, before supplying the hydrogen into the combustion chamber, we can place this flame trap. So flame trap, in case if you have, actually this is the pipeline, through this hydrogen will be supplied. And in case of backfire, if you have backfire through the intake manifold, if the flame, if it comes like this will get extinguished because of this mesh. Here you will have some kind of mesh like arrangement. So this will prevent the backfire. So this flame arrestor, flame trap can be used for minimizing the backfire of the hydrogen. And this flat piston also helps in minimizing the hot spots. Then 2 spark plugs. We can also use 2 spark plugs, and quickly we can combust the hydrogen by using the 2 spark
Excuse me,
plugs.
sir.
Yes.
Okay. So now only it is moving. Our screen is not, slides are not scrolling. That's why I asked you, sir. No problem, sir. You can continue, sir.
Is it
Okay, sir. Yeah, it is now scrolling, sir. Okay, sir.
Oh,
Okay, sir. Okay, sir. Fine.
okay, okay. So the next method in engine design is using two spark plugs. ரெண்டு spark plug வச்சீங்கன்னா quickly the flame propagation can be achieved. Quickly you can combust the air fuel mixture inside the combustion chamber. By that way you can avoid backfire. Then the third one is about the cold rated spark plugs. So in our spark ignition engine we use spark plugs. We have hot rated and cold rated spark plugs. Generally for hydrogen fueled engine, cold rated. So cold rated apina so if you look at this figure, you can understand what's the cold rated. So the height of the cold rated plug will be smaller than the hot rated, because in our hydrogen fueled engine, the heat must be quickly transferred to the top. If heat is retained here at the tip, if the heat is retained, then what will happen? This spot will act as hot spot. This one will act as hot spot. So the heat must be quickly transferred to the top. So that's why cold rated spark plugs are preferred for our hydrogen operation, hydrogen engine. And also cold rated with non-platinum tip. Actually, generally platinum will be placed here in our spark plug. This platinum should not be there in our hydrogen fueled engine, because the platinum will react with the hydrogen and it will have some other effects. So to avoid that, non-platinum spark plugs with the cold rating is important. So this is about the engine design, under engine design. Then also by providing crankcase ventilation, you are aware of what is crankcase ventilation. So crankcase ventilation means in our generally in our spark ignition engine or in diesel engine also. Let's take spark ignition engine. So in the spark ignition engine, we are supplying the air fuel mixture during the suction, and it is compressed during the compression stroke. Because of the gap between the piston and the combustion chamber wall, the compressed charge will try to enter into the crankcase. So if the engine continuously runs, then you will have the possibilities of the fresh charge getting accumulated in the crankcase. So accumulated fresh charge in the crankcase, sometimes if you have any kind of hot spot present in the crankcase, and with the accumulated fresh charge with the hot spot, you may have the possibility for explosion of the crankcase. Particularly in our hydrogen fueled engine, this is very, very important. So the charge entering into the crankcase must be expelled out. It must, that's why generally in our engines and all, we will have breather plugs in our crankcase. So through the breather plug, the accumulated air fuel mixture will go out to the atmosphere. So this will have hydrocarbon emission. On the other hand, the fresh charge can be, through the breather plug, the fresh charge can be admitted into the intake manifold. This is called as positive crankcase ventilation. You are aware of. In our hydrogen fueled engine, this crankcase ventilation is very, very, very important. Otherwise, you will have dangerous effects. So these are all the ways for preventing flashback and pre-ignition with the hydrogen fueled engine. So these are all some of the arrangements we can adopt in our engine for using hydrogen safely. Now let us see how to use hydrogen in internal combustion engine. So as I told you, hydrogen can be directly used in spark ignition engine, because hydrogen has a high self-ignition temperature, hydrogen has a very high octane number, hydrogen can be easily mixed with air. So because of all these reasons, hydrogen is best suited for using in our spark ignition engine. In the unmanned, if you want to use effectively the hydrogen in the engine, then you have to go for doing some modifications. I already told you, by changing the compression ratio, by increasing the compression ratio, by advancing or retarding, particularly retarding the timing, spark timing. So by doing modifications, you can effectively use hydrogen. On the other hand, in the unmodified engine, just you can up to 20%, you can use hydrogen as a supplementary fuel. Even 20%, 30% also can be possible with gasoline in the unmodified spark ignition engine. You can use hydrogen, and in diesel engine, in the compression ignition engine, no doubt that hydrogen should not be directly used because the auto ignition temperature is very high for hydrogen. So auto ignition cannot be possible in the compression ignition engine. If you want to auto ignite, then your compression ratio must be 30 or 40. So that kind of engine is impossible to develop. So compression ignition is not possible. Hydrogen, and also if you look at the C10 number of hydrogen, C10 number is very low. That's why hydrogen should not be directly used in compression ignition engine. Whereas hydrogen can be used in compression ignition engine in the dual fuel mode of operation. In the dual fuel mode, you can use hydrogen as fuel. So this figure shows a typical laboratory experimental setup for using hydrogen. Actually, this setup is for the dual fuel engine in the laboratory, how to use hydrogen. So hydrogen, actually this is the engine coupled with the dynamometer. So here we have the emission analyzers connected with the exhaust pipe. We have the data acquisition system. See here, if you look at this one, this is the hydrogen. So hydrogen before supplying into the combustion into the engine, it will be supplied through the flame trap. Flame trap. This is the hydrogen flow meter into the intake manifold. It is supplied. So this is the general setup. Actually, this is the setup whatever we used in our lab. In our lab, 5 of my PhD students are using hydrogen as fuel. But in the diesel engine, they are using in the dual fuel mode of operation, and they have very good results, improved results. But in our case, in our discussion, I told that hydrogen can be used directly in our spark ignition engine. So I will discuss some results of the engine with hydrogen as fuel. So here you can see the engine results with hydrogen as fuel. So this is the engine where the speed was varied and gasoline and hydrogen were used as the fuel. Actually, if you look at this figure, this first one is representing the actually this one is brake thermal efficiency. This is not brake power, brake thermal efficiency, and this you can multiply this one by 2. Actually, I made a mistake here. This is brake thermal efficiency. Actually, you have to multiply this one by 2. So if you look at the graph, the hydrogen resulted in higher thermal efficiency. At higher engine speeds, hydrogen resulted in higher thermal efficiency as compared to gasoline. This is because of the fast combustion rate. Better mixing of air and fuel, flame quenching was minimized. The rapid combustion helped in achieving constant volume combustion. So all this, because of all these reasons, hydrogen resulted in higher thermal efficiency. And also, if you look at the exhaust gas temperature is lower for hydrogen, mainly at higher engine speeds. You can see that the thermal, the exhaust gas temperature is lower. So if the thermal efficiency is higher, then your exhaust gas temperature will be lower because the energy released is utilized for useful work here. That's why energy wastage is minimized. So the exhaust gas temperature is minimized. And if you look at the next slide, the hydrocarbon and the carbon monoxide emissions. Obviously, if you look at the HC and the CO, the hydrogen resulted in lower hydrocarbon. The blue one is hydrocarbon. For hydrogen, black one is for the gasoline. So hydrogen resulted in small amount of hydrocarbon and small amount of carbon monoxide. But I told in the very beginning that hydrogen will result only in water, no hydrocarbon, carbon monoxide. Then how is it possible? You can ask. Even though it is minimum, as per my statement, the hydrocarbon emission must be 0, carbon monoxide must be 0. But in this case, there are hydrocarbon and carbon monoxide emissions. Actually, I took these graphs from the literature survey, from the research paper, but the author, what he is answering for this, the author is saying that the hydrocarbon present in this graph is because of the fuel, whatever he used, is not pure hydrocarbon, pure hydrogen. So hydrogen, if you look at the hydrogen flame is a colorless flame. You cannot see any color. If you have color, then the color may be because of some other hydrocarbon present in the gas. So some other hydrocarbon, maybe methane or any other hydrocarbon might be present. Because of that one, we have a hydrocarbon. He is telling like that. In addition to that, what the author is telling is this hydrocarbon and carbon monoxide may be because of the burning of lubricating oil. So inside the combustion chamber, lubricating oil might have been burnt. Because of the burning of the lubricating oil, this hydrocarbon might be present. The carbon monoxide also might be present. He is saying like that. But for pure hydrogen combustion, you cannot see any unburned hydrocarbon or carbon monoxide. If you look at the next slide, this is for the oxides of nitrogen. Oxides of nitrogen. If you look at for hydrogen, the nitric oxide is higher than gasoline. This is because the hydrogen combustion results in a higher temperature, cycle temperature. Immediately after the combustion, if you look at the combustion temperature, because of the rapid combustion, the cycle temperature was higher than the cycle temperature of gasoline. And also gasoline is a volatile fuel. Because of the volatility, because of the vaporization behavior, the charge temperature might be lower than the charge temperature of hydrogen air mixture. And also the peak cycle temperature is lower for gasoline as compared to hydrogen. That's why hydrogen resulted in higher NO emissions. So this can be minimized. The higher NO can be minimized if you introduce water. If you inject water along with the hydrogen air mixture, you can minimize the NOx emission. In addition, you can go for EGR for controlling NOx. So these are some of the results of the spark ignition engine fueled with hydrogen. Then the next and last topic for our discussion is about the hydrogen storage. I told about the handling, fuel safety, fuel handling, and all. In addition to that fuel safety, because of the low ignition energy, high flame speed, storage of hydrogen is also a challenging task. Storing, generally, hydrogen is a very light gas. So, and also it's a gas. It's a gas. It is not a liquid or solid. It is a gas, and it is a light gas. For having sufficient energy for traveling, for example, for our automobile, for travel up to certain distance. For example, from Chennai to Trichy, if I want to travel, then I will pour some 15 liters of gasoline in my car and I will travel. But if you want to travel 300 kilometers, 400 kilometers with the hydrogen, you must have hydrogen compressed at very high pressure, 200 bar, more than 200 bar. So you have to compress the hydrogen, store the hydrogen in specially made containers with thick walled cylinders. You have to store hydrogen for sufficient energy for traveling certain distance. So the thing is that storing hydrogen in gaseous form is easy, but for storing hydrogen in gaseous form, you need special containers. So if you keep all these cylinders in your car, the cylinders will occupy. I mean, it will have 50% of your car weight. So unnecessarily, you have to carry the weight of the cylinder. So this is the drawback of hydrogen using gaseous hydrogen. That's it. But nowadays people are thinking of actually people are doing research in using storing hydrogen with the composite walled containers with lightweight containers also. They are doing research and they have successfully developed such storage containers with composite material. But generally speaking, for storing hydrogen in the gaseous form, thick walled huge containers with more weight is required. So if you want to travel with the hydrogen, then you have to keep this cylinder in your vehicle, and your vehicle will unnecessarily will carry the weight of the cylinder. So this is the drawback. Then instead of going for storing hydrogen in the gaseous form, we can convert for having more energy content. We can convert the gaseous hydrogen into liquid hydrogen, LH2. But for converting the gaseous hydrogen into liquid, you must have minus 250 degrees centigrade, minus 253, very low temperature. So the boiling point is minus 250 degrees centigrade. So very low temperature, cryogenics technology, that technology has to be adopted. If that is the case, then your hydrogen, liquefied hydrogen will be very expensive. So 1 liter of petrol is 84. 1 liter of LH2 will be several thousands. So very expensive. That's why still it has not come into market. But instead of having a gaseous hydrogen, we can have liquid hydrogen. It will have more energy content also. But minus 250, we have to cool it. So this is another challenge, another way of storing hydrogen. The third way of storing hydrogen is in the form of metal hydrate. In the form of solid form, in the form of metal hydrate with metals, combining hydrogen with metallic alloys, we can store hydrogen. So just by heating the metal hydrates, we can produce hydrogen and we can use it. Still work is going on in storing hydrogen because it will also occupy more space, and the production hydrogen outcome will be very small. For more amount of metal hydrate, you will have less amount of hydrogen. So the easy way is storing hydrogen in the gaseous form, but the problem is a huge weight and also explosion. In case of explosion, dangerous explosions, dangerous effects will be there. It will not only affect the car, it will affect the surrounding cars, the surroundings also. So that's why still people are working on using hydrogen safely. So safety is the very important issue in our hydrogen usage. Otherwise, hydrogen is an excellent fuel, I can say, excellent fuel of the future, because combustion of hydrogen results only in water. So there is no need for costly emission control techniques, emission norms, BS4, BS6, BS8, no need of any emission norms, because hydrogen combustion will result only in water. Of course, NOx will be there, but NOx can be easily controlled. But the problem is handling, fuel handling, storage. So these are all the issues we have to address. We have to overcome the issues. So with this, I stop. So coming to the closure, we have seen that hydrogen has unique properties, extremely unique properties to use as fuel in internal combustion engines. Hydrogen can be produced from renewable sources, mainly by the gasification process. We can produce hydrogen in bulk. The problem with the hydrogen is pre-ignition and backfire, because of low ignition energy and a high flame speed, widest flammability limit. You will have a pre-ignition and backfire that can be minimized, overcome by number of methods. Hydrogen can be directly used in spark ignition engine because of the favorable properties. Hydrogen can be also used in compression ignition engines under dual fuel mode of operation. If you look at the storage, hydrogen can be stored in gas, liquid, and in solid forms. So with this, I stop. I thank you very much for your time and for your patience. You can have, if you want, you can have questions.
Sir, good afternoon, sir.
Yeah, good afternoon.
Dr. R. Palanichami again.
Yeah, welcome, sir.
Sir, by seeing the properties of hydrogen and the hydrocarbon fuel,
Hmm.
you said that the auto-ignition temperature of hydrogen is high,
Yes.
but the energy is low. Ignition energy
Ah,
is
yeah,
low.
yeah.
But the properties seems to be hydrogen having higher specific heat.
Hmm.
So if higher specific heat and higher auto-ignition temperature require higher ignition energy, but you said that hydrogen require low ignition.
No. So,
So it
actually,
is contradicting.
yeah. That thing is that it is all the results, whatever I have shown, no, the properties, all the results are proven experimentally by the experts, proven by the experimental methods. People have done a lot of research. From their research, they have proven. So, actually, the difference between the ignition energy and auto ignition temperature, I'm telling you. See, for auto ignition, hydrogen without, see, for example, flash point is there, auto ignition temperature is there. You are aware of what is flash point. So, the flash point means you must have ignition source for creating the flash. So, flash point is the minimum temperature at which when the ignition source is brought, close to the when the ignition source is brought close to the fuel, then if the fuel gets ignited, then that point is called as flash point. Okay, so for that, what in our experimental, what we are doing, just we are heating the fuel, we are heating, and we are bringing the ignition source close to the fuel, and we are checking the temperature. At what temperature you have flash, then that point is called as flash point. But in case of auto ignition temperature, there should not be any ignition source. The fuel must automatically get ignited. So that is called as the auto ignition temperature. So that temperature is higher for hydrogen. But hydrogen can easily catch fire if you have ignition source. So there is no relationship between auto ignition temperature and ignition energy.
But for our combustion, the auto ignition or self ignition temperature is very important.
Yes, self-ignition temperature. Sir, that's the thing I'm telling, sir. Self-ignition temperature means without any ignition source, the fuel must automatically get ignited. In case of diesel engine, there is no ignition source for diesel. Diesel is automatically getting ignited. Because of the heat of compression itself, the diesel is catching fire automatically. Because the self-ignition temperature of diesel is 260 degrees centigrade. So that automatically it must catch fire. That temperature is called as a self-ignition temperature. But ignition energy is different. That is the thing I told you, for the sparkler. For the sparkler, you have a candle flame and a firing sparkler. In both the cases, if you measure the temperature of the flame, the candle flame and the firing sparkler flame, the temperature will be almost similar, same. But for firing the
ignition energy,
that ignition energy
is given to.
No, the intensity spark. See, for example, in gasoline engine and all, we have to provide 20,000 voltage. So very high intensity spark is required. Not just a spark will ignite the gasoline air mixture. So that ignition energy I'm telling. In case of hydrogen, that much energy is not necessary. See, in case of a spark ignition engine, in case of spark, yes.
Ultimately, the ignition energy supplied to the fuel is going to raise the temperature. So once the temperature reaches the auto ignition temperature, the fuel will burn. That is the theory.
No. See, ignition energy will not rise the temperature. See, temperature, for example, in our spark ignition engine, what we are doing, we are compressing. We are compressing the air fuel mixture. Because of the compression, the temperature is increased. The fuel temperature is increased.
Yes, sir. That is
also
not sufficient.
that
temperature is not sufficient.
Yes.
That is why we are giving additional energy. Locally, we are giving additional energy.
Yeah, that's
locally we are giving additional energy. That energy is.
Yeah, that's it. That's why I'm telling you, because the gasoline, the self-ignition temperature of gasoline is more as compared to diesel. In addition, even with so the same thing we can achieve in our spark ignition engine also. For example, by compression, by the heat of compression also, we can achieve combustion in our spark ignition engine. But in that case, you have to increase the compression ratio of the engine. So increasing the compression ratio in spark ignition engine, in that case, if if gasoline has to be auto ignited, then your compression ratio must be 20 instead of 16 in diesel engine. But arriving 20 for any spark ignition engine, arriving 20 as the compression ratio will make the system complex. So then you must have huge flywheel, you will have balancing. So making such kind of design in the engine is very, very difficult. Instead of that, if you have spark, you can easily ignite the air fuel mixture. That's why we are going for spark ignition. So the same thing, what I wanted to say is, in our diesel engine, diesel is automatically ignited. The same thing we can follow in our spark ignition engine also. But gasoline's self-ignition temperature is 400, 450, very high. So for arriving that much self-ignition temperature, you must provide more compression. So in that case, your flywheel must be huge. Your system will, I mean, the engine design will be complicated. Instead of going for that one, just a spark can ignite. Still, you are not convinced?
Yes, sir. Yes, sir.
Anyway, we will discuss, sir. Any other questions? You can.
Another doubt is the stoichiometric reactions require 4 kilogram of hydrogen requires only that is 29 kg of air.
34. Just I will show that.
Oh, okay, sir. Okay.
Yeah. Sorry, sir.
Yeah. Correct, sir. Okay, so okay, no problem.
Actually, some you will have confusion because sometimes I used mass, sometimes I used volume. That's why you will have confusion.
Yeah.
4
4 kilogram requires almost 4 mole of
So next question, sir. Sir,
okay,
my
sir.
question is regarding.
I have some. I have to
you
clarify.
have shown hydrogen to be used in dual fuel and hydrogen to be used in SI engines. Why haven't you discussed about hydrogen to be used in what's that, fuel cell technology, and what about RCCA technology? Is there any complications in that?
You are talking about RCCI. So I don't know how far actually RCCI is recent technology. We are focusing on that reactivity controlled compression ignition. That I will tell you later. Regarding fuel cell, actually for fuel cell operation we need hydrogen. Okay, hydrogen will be combined with oxygen and directly we have electricity produced, current electricity produced in the fuel cell. But that is a totally different concept. That's why in the very beginning I told fuel cell technology is totally different. That you have endothermic reaction. Hydrogen will be combined with oxygen and you will have electricity. But in our case, exothermic heat is released. Fuel is reacted with oxygen. Then you have combustion. Heat is released. That heat is used for operating the engine. So this concept is different. That is different. Okay.
Okay.
So fuel cell, people are working on fuel cell also. Hydrogen is also used in the fuel cell. Electrolyzer, they are having electrolyzer, hydrogen generator, and they are operating the fuel cell. That is a different concept. Our concept is different.
Okay, sir.
Then you are telling, you are talking about RCCI, no?
Yes,
the
sir.
RCCI is nothing but a reactivity controlled compression ignition engine. It is something like our dual fuel engine. Actually,
Yes, sir.
in our
It's almost
dual, it is similar to our dual fuel engine only. It is a diesel engine. We are in our dual fuel engine. We are trying to operate the diesel engine in spark ignition engine mode. So partially in
Yeah.
spark ignition, partially in compression ignition. So dual fuel mode. So by that way, we can have a higher thermal efficiency. Actually, for our research scholars, we are using hydrogen as a fuel supplement, as a primary fuel for improving the vegetable oil fueled diesel engine.
Okay,
So,
vegetable oil.
yeah, for improving the combustion of vegetable oil, we are trying to use hydrogen, and we have
Yeah,
good results. We have
yeah, I
good
just
results.
got the ITC from the research article. Sir, you have mentioned that your research is regarding biofuel, like direct use of vegetable oils, right?
Directly, sorry, can you repeat?
It is like direct use of vegetable oils. It's not like using biodiesel.
No. Directly using the vegetable oil, not biodiesel.
Okay,
For
I've
him,
seen this. I've seen this mango oil to be very uh, easy form, like kept idle.
sorry,
So,
sir, I am not able to. Can you repeat once again, please?
sir, this mago oil I have seen your
Yeah,
research paper,
yeah, yes.
and I have been using that oil to be comparing with some other equipment. So it is in a greasy form. So how can you make it possible to run in a so without preheating? Is there any possibility, or
Yes,
what
sir.
is the method you use?
Sir, some audio disturbance is coming. So, magu oil, you are saying directly using magu oil is a problem like that, is it?
Yeah,
Can
it is like that because it is
uh,
in greasy form, right? So
yeah,
that's
yeah,
why I'm.
yeah, yeah. Actually, for our case, the temperature after 30 degree centigrade, we did not find any semi-solid form of magu oil. If it is, for example, at a cold climate, like in winter, we observed that the magu oil is in solid form. So we used to heat it up to 30 degree. We are not heating up to 50 or 60 and all. That will have some other reason. So up to 30 degree we
Okay,
are heating, and we are using it, no problem. For starting the engine,
okay,
we will use diesel. After starting the engine with the diesel, we will change the fuel supply to mahu oil. Then we also supply hydrogen. During the intake, we will supply hydrogen. And as per the conventional injection, we will inject mahu oil, and we have good results. We tried a number
okay,
of
sir.
methods, dual fuel, oxygen enrichment, like that.
Nice, nice. Nice.
Mm.
And I have never seen a paper of you being published in biodiesel. Is there any reason in that?
Actually, biodiesel, long back I used biodiesel, but all over the world, sufficient research have been made using biodiesel.
Okay,
So I am
okay,
not interested in biodiesel because,
that's fine.
but last few years and all, people they produced biodiesel. For producing biodiesel, it was, I mean, time was consuming, 1 day, 2 days, like that. But nowadays people have, they are doing this, and they have found methods for producing biodiesel quickly within few, not even few hours, within a few minutes. They are trying to produce
Yes, sir.
biodiesel. That kind of
Exactly,
approach
sir.
people
Exactly.
have, people have achieved
Okay,
producing
sir.
biodiesel quickly.
I'm expecting all those kind of researches from you, sir. That was my question.
Yeah, you are welcome. You are welcome. And in our department, we are going to establish one center called as Center of Excellence in Automotive Technology.
Oh, very
There
nice, sir.
we are going. We have ordered for that gasoline direct injection engine test bench. We also have.
Okay.
We are going to have a transient dynamometer. These are all very expensive equipment.
Oh, very nice.
Transient
And
dynamometer.
you will be one of the greatest institutions to do that, sir.
Yeah,
If you do
yeah,
that,
it
so
is there. It is there in IIT Madras only. The another
yeah, yes, sir.
institution is ours. We are going to have that transient dyno.
Yeah,
The cost is 3 crores.
research in cancer panel and make you reach higher
Yeah,
level.
please. Yeah,
Your
you are
intent.
welcome. Mm-hmm.
Thank you, sir. Thank you for your
Yeah,
time.
welcome. So,
Okay.
any other questions, sir, please?
Sir, you say that gasoline, hydrogen can be directly used in gasoline engine. Any
Yes.
cold starting problem because of higher specific.
The cold start may be there, Cold starting, if you have, you can have some blow plug or any heating element you can provide. But so far, I did not see any cold starting. I did not try with this one. Actually, in my case, to be honest, I have not tried in a spark ignition engine. But I have read in literature papers. In the literature paper also, I did not find any statement on cold starting problem with the hydrogen.
Sir, you mentioned
Yes,
about
sir.
flawed piston. Flawed piston. What is flawed piston?
அதான் சார் இப்போ டீசல் இன்ஜின்ல பாத்தீங்கன்னா டீசல் இன்ஜின்ல பிஸ்டன்ல வந்து பவுலின் பிஸ்டன் இருக்கும் ஃபார் கிரியேட்டிங் டர்புலன்ஸ். Bowl will be there. In case of petrol engine, you may have some kind of projections for turbulence, for creating turbulence inside the combustion chamber. For creating the turbulence, we will have some arrangements in the piston. So that kind of extra projections will act as hotspot. ஹாட்ஸ்பாட் அந்த இடம் பார்த்தீங்கன்னா அந்த இடம் கண்டினியூஸாக கம்பஷன் ஆகிட்டே இருந்ததுன்னா அந்த இடம் வந்து ஓவர் ஹீட் ஆகிட்டே இருக்கும். ஸோ அந்த மாதிரி ஓவர் ஹீட் ஆனதுன்னா தட் வில் ஆக்ட் அஸ் ஹாட்ஸ்பாட். ஸோ டு அவாய்ட் தட், இந்த ஃபிளாட்டாக இருந்ததுன்னா யூ வில் நாட் ஹேவ் எனி ஹாட்ஸ்பாட். ஈவன் இன் ஃபிளாட் பிஸ்டன் யூ மே ஹேவ் த டிப். திஸ் டிப் வில் ஆக்ட் அஸ், மே ஆக்ட் அஸ். So we are minimizing the hotspots. For the purpose, instead of having bowl in piston, we can have flat piston. Okay, sir. Is it okay or?
Okay, sir. Okay, thank you, sir.
Any other questions, sir?
Thank you, sir. This is Chandrasekhar, sir. Hello.
Yeah, sir. Yeah, good afternoon, sir. Thank you for the opportunity.
Very nice presentation, sir. Very nice presentation.
Okay,
I think
sir.
you covered starting from the basics of how to generate hydrogen gas, what are the property compatibility of hydrogen gas for application IC engine, and how to store that, and even you have touched upon the economics of hydrogen. As a closure, also you have neatly consolidated
Yeah. Because people
the
will
merits, the demerits, and also given the highlight is you have given some solutions also for all the demerits. Very interesting session and useful session. And the example also, the ignition temperature and the energy what you have given with the Diwali sparklers. It's very quite interesting. We can draw some parallel analogy. Very good example, sir. We are. I hope the participant will be benefited. If there are no questions, we can end the session, sir.
Yes, sir. But always you are welcome, sir.
One more thing, sir. One more thing, sir. Thank you for sharing that the setup of setting him up Center of Excellence in automobile.
Yes, sir. Yes, sir. You are welcome. இல்ல அது உண்மையிலேயே it's already 10 crores வந்து we have already purchased the equipment. 10 crores. Remaining actually the total cost is 50 crore. So for 10 crores we already purchased the equipment. Soon we are going to have excellent laboratory facility.
Yes, sir. Yes, sir. Thank you, sir. Thank you, sir. Participants will be definitely benefited by this, and researchers will be definitely benefited by this facility, sir.
Yes, sir. Yes,
Thank you.
Yes.
Thank you so much, sir. Thank you. And I just need to acknowledge you for this Center for Excellence. Hope you'll meet you soon there. And in a paper from Energy, sir, it is really excellent. It's, not all can just post the paper over there. It's really nice. All your papers and all those things, sir. Keep going, sir. Thank you.
Yes, sir. Thank you. Thank you, professors. Thank you all the participants for the patience and listening to my talk. And for further clarifications, for any kind of discussion, you are welcome. My email ID is given in the website. You can contact me through phone, through Professor Chandrasekhar. You can get the phone number, and you are welcome for any kind of discussion.
Thank you, sir.
Okay, sir.
Yes, sir.
Thank you.
Thank you, sir. Thank you for joining, sir. Thank you, sir.
Thank you.
Participants, we can now break for the lunch. I think we have already crossed the schedule again. Never mind. Okay, so the content are really good and hope it will be useful to you. And we shall meet exactly at 2:15 after the break. Okay, next session will be on biogasification. Thank you for joining us. We will meet again at 2:15. Thank you.